friends, this is sixth homework for Automata classes and we will solve these two problems now. Actually, the topic of this problem is a little bit confusing and I'm not sure if my solutions are true, so I already solved the problems because I tried to solve and even now I'm not sure if my solutions are correct or not. Um, our topic is about pushdown automatas, deterministic or non-deterministic. The first question is non-deterministic. The second one is about deterministic pushdown automata. Why do we call it like pushdown? Because we have memory here, stack memory here to memorize the actually our first or last letter to continue in our language or some operations like that. So this is our memory, and this kind of automatons we have made. If we use this stack memory, we call it like pushdown. And let me try to explain you. Yeah, that's okay. For the first question, it says construct non-deterministic pushdown automata to accept the language 0 to power of n and 1 to power of 2n. So there's a string like 0, 1, 1, 0, 0, 1, 1, 1, 1. We need to create an automaton to accept this kind of words. So how do I do it? I just try to create a stack operation which adds 1x to the top of my stack when it reads as 0, and when it reads 1 it continues with q1, and if there is one more 1 it it doesn't change anything, and if there's one more 1 that's 1x, and then it goes to exit state. So let's try it with these questions. Firstly, we are here and we have 0. It says read the 0 and add 1x top of the stack. After that, we are in the position of 1. If it's 1, pop the x and push an x, so anything has changed, and continue. And then if there is one more 1, continue with q3.3. So yes, there is one more 1, and it continues to do same thing. That's x, and that's one more x here. And if there is nothing, so I don't have something for that, let me create a connection here. If there is an epsilon, let's say epsilon, delete x, pop x, and epsilon, return epsilon, nothing. So we will reach to ground. So I think that's now okay. Let's check it for our this word. If I read 0, it adds 1x. If I read 0, it adds 1x. After it reads 1, it doesn't change anything. If it reads one more 1, it doesn't change. Yeah, it doesn't change anything. And if there is one more 1, it pushes x and returns q1. Yeah. And then if there is one more 1, it doesn't do anything, has changed, and we are again in Q3. And in Q3 we are reading anything epsilon and pushing popping 1x and returned epsilon, so we are in ground and except state. Yeah, actually I made a mistake here. So if we delete this transition, yeah, I think my automaton works like this. Is for first question. Let's continue with the second question. What it says: construct pushdown automata to accept the language any more A or B in the word, but first, middle, and last chars must be identical. It means if you start with A, you must finish with A. Also, your middle elements must be A. So I made a little bit confusing automata. So let's check this automata with our string identical. So let's try with a basic one, which is 3 A's. And one little mix it. Let's B A B A B. Let's check our automaton for the two words. So read A, add 1A to your stack. After that, we are in Q1, reading A, doing anything in stack. After that, read A, we have two choices here. So it means it's non-deterministic automata. Is it? Yeah. And so if in our stack at top we have A or B, we have A, so we will continue with this way. It says if it's an A and the stack has A in top, nothing has changed. Continue with Q3, and after Q3 we are in the third A. If it's A and top of stack we have A, so we are not using this way, we are using this way because A read stack A, push pop stack A, and push an A here. So we are in except state. So it works. It works. Actually, I think I need to change something like that to make it. It's I think not very important thing, but let's finish it in ground. So if it's A, yeah, return epsilon. So we will push the A and we will reach to Z0. It works for AAA. Let's try it for BABAB. We are reading B, pushing B to our stack. We are in Q1. After that, we are reading A. A or B doesn't matter. We are continuing with Q2. After that, we are reading B. And if we have B in stack, if it's BB, continue with Q3. If it's not, it's going to be returned here. But so if there's one more A, it will return itself. So it's because of it's not middle element and it's not same with the first element here. So it will return Q2 after it reaches the same element. And it becomes the middle element. So, but because of its B and it's the middle element, it continues to Q3 because we have B in stack. So it doesn't make any change in stack and continues with Q3. And we are in fourth step and Q3, it reads A. But in the stack we have a B, so we will continue with this step. We doesn't make any change here. We are still in Q3 because of we are here. after that, we have a B, and in our stack we have B. So we will continue this way, and we will finish in exception state, and we reach the Z0 because we pushed the B and we popped the B and we didn't push anything. So I think my automaton works for this rule, this language rule. So yeah, it is the finish. Thank you for watching my video.